Within Crab, I worked in a bunch of different roles. Not only did I work on the tech side, but I also had a hand in the VFX as well, as most of the audio. In this video, I will talk about everything I worked on, as well as give a deep dive into how I actually did it. For starters, let's talk about audio. In this project, I was the audio lead, and because of this, I wanted to make sure I did a great job of my sound. There was a lot of consideration involved within the audio in this game. For example, since the game takes place inside the robot, I wanted the UI to sound like it was produced by a computer, since it would help reinforce the mechanical feel of the game. For the actual in-game audio, I wanted to make all of the audio as immersive as possible since the game takes place underwater. Because of this, a lot of the sound is either muffled if it's outside, or a lot louder with the 3D audio attenuation if it plays inside the mech. Here is a showcase of all the sounds that I created.
Energy low. Oxygen low. Oxygen low.
Hello, this is a test for audio. As mentioned previously, I also created some VFX for the project. To try keep all of these optimized, I often use sprites quite frequently. Typically, I would also create the sprites myself, and I'm really happy with the result of all of them. Here is a video of all the VFX I created for the project. Other than the sound, I also worked on the initial C++ of the mech itself. I mainly worked on the movement of it, and because of this, I wanted to make sure that the parameters were very modular and easy to use for designers. This includes parameters for move speed, as well as an optional loop pool, which will allow the mech to loop around the path if it ever wanted to. For the AI, I helped with the health components, and once again try my best to make this as modular as possible for the designers. For example, you can apply VFX when an enemy gets hit, dies, and you can also play a sound when they get hit or die too. Another thing I worked on was the actual energy system that determines whether or not the player lives or dies. To create this system, I first of all created a new widget that housed 2 progress bars. Within these progress bars, I then created a timer which would update every 0.1 seconds, and every time the timer fires, the progress bars would update. The value these progress bars get actually come from a blueprint interface. This interface comes from the player itself, and it uses another timer which increments 2 floats every time. Because of this interface, I can use this in a variety of blueprints, without it costing too much memory. For example, I also use this interface on the mech, so when the current energy drops to 0 or lower, the mech would not only completely stop, but the crab steps would also stop playing, leaving the player to only hear the ambience of the ocean. To regenerate these energy sources, you have to first of all hold left click on one of the 2 pickups and drop them into their corresponding consoles. These consoles find out what the pickup is, based on the interface that it has, and uses an enum to choose what type of energy increases. For the actual pickup code, I utilize the physics handle component, and allowed me to use the grab component at location and rotation node. The timer then fires, which keeps the object in the same place. Finally, I also worked on the crack system of the mech. To create this system, I first of all made a blueprint which would display a decal whenever a certain interface triggers, and then disables it when another fires instead. I then went into the mech blueprint and added them all as child actors. Next, I made a function which would create a temporary array which would hold every child actor. I had to do this as there was no way to create an array with actors normally. Once this function was complete, I went to the health section of the mech and changed it so whenever the mech's health reaches 0, it would reset and a crack would spawn. To create this crack spawning mechanic, I had to create a new variable which would generate a random int. This integer would then get passed through a compare node, and if this number isn't already in the new array I also created, then it would add it to said array, and the while loop will stop firing. This array contains IDs for a random crack from an array, and once this while loop is completed, it will get this random ID and use the create crack interface created previously in the other actor. I also made sure that there was not any chance for infinite loop to occur, and that was by creating a branch to check if the array has equal or more items than 10. If this is the case, then it will not fire the rest of the code. Next, I worked on the influence of the cracks with the oxygen. To do this, I got the length of the entire array and made it affect the value that decrements the oxygen value. Therefore, the more cracks spawn, the faster the oxygen will deplete. To then destroy these cracks, you have to first of all walk up to them and press E to interact. Once this interaction takes place, a random ID from the array gets chosen, and not only destroy the chosen child from the index, but also remove the index entirely. This way we don't have weird issues. Finally, I did a branch to check if there were more than 0 indexes, and if there wasn't, the rest of the code wouldn't fire. This was done once again to stop any crashes from occurring.